All right, so today is Tuesday, August 30th, period 1, algebra 2, and we're looking at more systems of three variable equations. On page 33, we have an example of what they consider to be a solving real life problems. It says, let's go ahead and read it out loud. It says an amphitheater charges $75 for each seat in section A, $55 for each seat in section B, and $30 for each lawn seat. Okay, so there's one statement. The next sentence reads, there are 3 times as many seats in section B as in section A. There's another statement. And finally, the revenue from selling all 23,000 seats is $870,000. How many seats are in each section of the amphitheater? Okay, so let's be clear on revenue versus profit. Revenue, we're talking about, that's just income. Okay, profit is after you deduct expenses. So revenue is just what's coming in. Okay, so let's see if we can make some algebraic statements from these statements that are in English here. So an amphitheater charges $75 for each seat in section A, so this much for B, and this much for each lawn seat. Okay. So the idea that you guys want to have here, let me click what this is. This is page 33. Page 33. Example 4. Hello, Skylar.
Hi.
This is where we are.
Okay.
Okay. I'm going to always choose something that makes life easy when I set my variables. But this is the verbiage you have. Let A. Now, do we want A be the number of seats in section A? Because we know how much each seat in section A costs. So what's the unknown? The unknown, I think, is the number of seats. How many seats are in each section? So let A be the number of seats in section A. Okay, and this is the idea. So then let B be the number of seats in section B, and then we're gonna let L be, they don't call them lawn seats, do they? They do call them lawn seats. Let L be the number of seats in lawn. I highly recommend that you do this. That if not on paper, I want to say do it on paper, because here's the thing. You're going to start doing the math, and then you don't want to get lost in the math, and then forget, oh, what does A mean? What does B mean? What does L mean? If you set your variables immediately, know what they mean, then they'll always mean that through the whole problem. Okay. So we have this statement first. Okay, so what equations can we write? I know that it's in the book, but without even looking, an amphitheater charges $75 for each seat in section A, $55 for each seat in section B, and $30 for each lawn seat. Okay. Can we make a statement just from that, an equation? I don't think we can. It tells you how much each seat costs, but we can't do anything from just that alone. Okay. There are 3 times as many seats in section B as in section A. Now, definitely we can write something from that. There are 3 times as many seats in section B as in section A. Okay, so what can we write? the revenue from selling all 23,000 seats. There's a total of 23,000 seats. So we should be able to say this. The revenue from selling all 22,000 seats is $870,000. So $75 is how much they charge for a seat in section A, plus they charge how much for a seat in section B, 55. Plus they charge $30 for a lawn seat. So the total revenue, if you added up $75 for all the seats in section A, plus $55 for all the seats in section B, plus $30 for all the lawn seats, this should equal a total revenue of $870,000. Please raise your hand if you don't understand one of these equations, like how it came from the text, or how it came about it. Yes. The first one, B equals 3A? This? Okay. This is saying I'm going to let this letter represent this idea. And this is one of the fundamental keys of algebra, is to let some letter represent an unknown quantity. Okay? So you're allowed to do this. I'm just saying I'm going to let the letter A be the number of seats in section A. Because I don't know how many there are off the top of my head. Okay? I'm going to let B, and you understand all these little double quote things, what they mean? That just means the word above it. That's a short way of saying, like, okay, this means let B be the number of seats in section B. That's a short way of it. It's not to write the same exact words again. Is that good? Okay. Anyone else? Any questions about these? Because this can be maybe the toughest part of this, or at least it is definitely considered a tough part of answering is getting this set up. Because I've noticed some students, they'll get one or two, but they can't get all three. Any questions about this before we move on to the actual math? Because you have to get this, you have to set it up first. Okay, everyone gets it. Great. What I'm going to do is we're going to move on to another page. This looks like the copy button. Okay. Grouped? No. No. So you got to do edit copy. You'd think they'd have a shortcut for edit copy and paste. Okay. You guys that are in the back, which is probably why you can sit up closer, it's probably better. Can you guys read that in the back all the way back? Everyone in the back? Clear? Okay. Would anyone like to attempt this? Whether it be telling me what to do or coming up and trying it? Anyone want to take a shot at it? It's like a puzzle. Trying to figure out what A, B, and L are? No? Alright. Alright, so let's figure this out. Anyone have any idea maybe where you want to start with something like this? What's that? It looks different. Okay. What makes it look different? Yeah, what makes it look different? This is good. This is collaboration. I want to know what you guys are thinking. Does it look different because you have variables on the left and right? Is it because one of them only contains two variables? Okay. Right. So two of them contain all three, but only one of them has two variables. Okay. That is different. So you can think of it like this: that you basically have, for those of you that understand things graphically, each of these would be a plane, right? You guys know what a plane is? And this would be a line, graphically. Algebraically speaking, this is actually more convenient for you because this guy only has two variables. So we're probably going to get to the solution more quickly because that guy only has two variables. Okay, so I look at this, and I think we all like the process. I like the process of elimination. You can do substitution if you want. I'm going to stick with elimination because I think it's easier to try to eliminate different elements. So I look at this. I know that if I did something right now to the first two equations, I could quickly get rid of the b's. Right? If I subtracted, let's say, either the second one from the first one or the first one from the second one, doesn't matter. The b's will go away. Okay? I look at the third one, and I don't like how large these coefficients are. Could someone with the calculator, let's see if we can simplify this. Could someone with the calculator please tell me if, let's see, what's the largest number I could at least make this more simple? They all have 5 in common. I think 5, because the prime factorization of this is 5 and 11. And I know 11 is not a factor of this. So could someone tell me, let's go ahead and divide this whole thing out by 5, and let me see how I could write this. If I divide this whole thing by 5, it'll make it the same equation, just more simple. So I'm going to do that. I'm going to, let's see how I'm going to show this. Probably I'll do a different color just so it's so clear. I'm going to take this, and I'm going to divide each side by 5. Are you guys cool if I do it that way, or do you guys need to see me do bracket on the left side and bracket on the right and show division of both sides? Instead of just this kind of lazy thing here, it's kind of lazy, but you guys get the idea when I do this that I'm going to divide both sides by 5. Are you guys cool with that? Yeah. Okay. Someone with a calculator, please help me out. What is 75 divided by 5? Okay, so I have 15a. Let's go ahead and go one notch down. So I have 15a plus 11b plus 6l equals, what's 870,000 divided by 5? 174,000? 174,000. Is that still legible back there, especially the guys in the back? Okay. I don't know about you guys, but I prefer dealing with this than dealing with this. All right, so I'm going to divide out if there's a common factor out of all my terms, and I mean this, and this. When I say all my terms, I'm going to divide that out. I'm going to make it more simple for me. Okay. I still find that in terms of starting the elimination process, I'm going to deal with these two guys first because those b's go away immediately. So let's go ahead and let's take care of that. Let me label these equations. We'll call this one say this is the first one. This is the second one. And I'm not even going to use this guy anymore because all I do is divide both sides by 5, so it's still equivalent. It doesn't take away any possible solutions by me dividing by a constant. That doesn't affect it at all. And I'm going to call this guy the third one. Okay, so let's deal with 1 and 2 because I think you guys see B and B is going to go away quickly. So let's do that. Let's do what would be 1 minus 2. Let's do that process. I'll show the work. So B equals 3a. I have A plus B plus L equals 23,000. Okay, so if I subtract, subtraction sign, I hope that's clear. If I do this, okay, so let's do this. There's no a here, right? So what's 0a minus a? 0a minus a? I hear a, but that's not the right, that's not it. 0a minus a would be, what's 0a? This is nothing. So what's nothing minus a? Negative? Negative a? Yeah, negative a, so be careful. You guys, if you're having, you can always do a number line, by the way. If you're having any, I'll do it on a different slide here. I know you guys know a number line, the basics, like you have 0, 1, 2, -1, -2. But we can literally think of a number line in terms of some variable. Like if I had 0a, 1a, 2a, -1a, -2a. So if I say what's 2a minus 3a, boom, 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 you would end up at -1a. So you can do that with a number line. Okay, so back to here. All right, so I have a b. What's b minus b? The whole reason we did this was to eliminate the b's. So they're gone. I don't have an L here, so what's 0L minus 1L? -1L, yep. I could write plus -L or just write minus L, it's the same thing. Equals 3A minus 23,000. What would that be? It's almost like I'm asking you a trick question. 3A minus 23,000. Thank you. Why? Because they're not, I can't combine them because they're not like terms. They're not. This is an A term, this is a constant. So I can't do anything. It's as simple as it gets. Okay, so this might answer one of the questions that some of you guys may have been thinking when you look at this problem is, do I have to have all my variables on one side? Not necessarily. Not necessarily, but it's important that I line it up in such a way, though, that I am able to eliminate at least one of my variables. Now, if I can eliminate 2 at one time, then I'm definitely going to, minus 3 on each side of this, and so it says -3a plus b equals 0. If that guy was also -3, but it's not, so it's not not necessary for me to subtract 3a first. You guys see that? It wouldn't eliminate the a's anyway. So the a's are going to be there, but I definitely needed to eliminate the b's, so I did not care about the 3a being on this side or -3 on this side plus b equals 0. It doesn't matter to me. Okay, so now we're here. This is absolutely correct what I have written here. I probably would want to, maybe to clean it up a little bit, I'd want to probably bring all the variables over now because I'm going to be dealing with this guy. And I'm going to be dealing with this guy either with 3 combined with the 1 or 3 with the 2. Because remember, the major rule is I chose to work with 1 and 2 first, right? I chose to do something to eliminate the b. I'm indifferent. Where'd you come from? Was you just late?
I forgot my violin at home, so I did it all the way back.
Okay. I've already dealt with these 2. I have to deal with this guy. Now, because I eliminated a b here, I need to deal with this guy, and I don't care whether it's 3 with 2 or 3 with 1. But I need to eliminate my b's just like I eliminated my b's when I dealt with these 2. So because I have to deal with this guy, what would I want to deal with here? This looks a lot nicer to me than this does. I'm going to go with 1. I'm going to go with 1. So let's go ahead and let's do that. Let's go with 1 and see if this works out. So I have this guy here. I have an 11b here, but I have 1b here. So that in order for the b's to either be the exact same or the opposite, depending whether you add or subtract, I need to do something with this. So let's multiply. Let's see if I bring this guy down. I'm going to do what would be 11 times this guy. So 11 times the first equation would result in 11b equals 33a. And again, I really don't, because this would not look exactly like 15b if I got rid of it on the right-hand side, I don't care about bringing it over. So I can do that at the end. But if you guys are comfortable and you want to bring all your variables over before you do this, go ahead and do that. All right, so I'm going to subtract. Let's go ahead and subtract this whole guy. And notice I'm being very careful. Parentheses. Otherwise, you might make the mistake where you end up subtracting this guy, but then you don't subtract this term here. So be very careful when you do this. 15a minus, there's no a over here, so that's still 15a. 11b minus 11b, the whole reason I did this, so that we have nothing. And then 6l minus no l, so we still have positive 6l. And this equals 174,000 minus 33a. Of course, I'm a little tight on room here, so I'm going to look a little not the best. Minus 33a. I think you can get the idea. Okay, so now I've developed this equation from dealing with these two guys, and now this one from dealing with equation 3 and some multiple of equation 1. Now I have two equations that are in two variables, and this is where your current homework assignment, you're dealing with things like this, systems of two variables. I can probably tell you this. I have a prediction. If I get solutions that do not work, my mistake is going to be made when I chose to do 3 and 1, because this is just a line and not a plane. I have a feeling if I make the mistake, that's where the mistake is going to be made. But I think we'll be okay, because I am incorporating all of them simultaneously. And now we're going to look at these two lines. Okay? So let me clean each of these up. So this guy here, I think it's just nicer to have all my A's and L's on one side. So let me just go ahead and subtract. You know what? What I'm gonna do is I'll do this. So it's all positive. I'm gonna add A, I'm going to add L, and I'm going to add 23,000. To each side, right? Because you're allowed to do whatever you do to one side as long as you do the other. And so if I did this, I would have, and I'm also going to flip at the same time, I would have 4A plus L equals 23,000. Is everyone good so far? Please raise your hand if at any point you got lost as to why I did anything up to this point. Where'd you get fuzzy? On here? Okay. You understood this, right? This is this equation here. I just divide 5 on each side, so it's the same exact same equation. Are you okay with that part? Okay, but you're getting fuzzy on what I did, this whole thing here? Okay. So because I dealt with equations 1 and 2, I need to do something with 3. Whether it be 3 dealing with, 3 being combined with 1, or 3 being combined with 2, I have to do with 3. So I'm like, okay, here's equation 3. And I want to eliminate the b's because I eliminated my b's when I dealt with these two, this part of the system. I need to eliminate the b's when I deal with 3 and one of these other guys. In order for me to eliminate the b's, if I decide to take equation 1, well, I have 11b as my term in equation 3. I need to write it so that this is also 11b. So I multiplied both sides by 11. That's what this means here, 11 times equation 1, and wrote it here. So this here is 11 times equation 1. And by doing that, notice I can eliminate the b's. So eliminating the b's was the big component of this work here. Does that make sense? Yes?
How did you get 4A?
How did I get, okay, so yeah, this, I did it all in one step. So, but I still show my work though, because I'm showing, okay, I'm adding this, this, and this on this side, and I'm adding, you're allowed to do whatever you want. You guys understand that. Let me repeat that again, that you're allowed to do whatever you want to both sides, except divide by 0, which you're not going to do. So let's see how I got 4A. So what I did is, negative a plus a, that gets rid of these a's. Negative l plus l, that gets rid of these l's. And I'm just left with 23,000 on this side. So imagine this says 23,000. On this side, this goes away to nothing. 3a plus a is 4a, and no l plus 1l is l, and I just reflects it. It's like a equals b, b equals a kind of thing. I know I did a lot in one step, so I'm glad you asked about that. Yes?
How would the negative 20,000 be?
Yeah, let me do this, because this might make it a little more clear if I'm allowed to just group that. There we go. Let me show this. So really, this is really what's going on. This might make it more clear. That really would be the step from here to here. I just did it in one thing. Does that make sense? Do you see it now? It's okay if you don't. Do you see it? Okay. Yes.
Wait, but why are you adding an A if you're already eliminating the A?
Oh, no. I eliminated these. Once I had this guy, I ended up I just wrote so all my A's and L's on one side.
Oh, okay.
Yeah, I eliminated the B's from there, and then I'm going to eliminate the B's from there. No? Okay, it's not in your lap? Okay. All right. Fine. Please don't play on your phone during class. So, any other questions? All right. These take a lot of time. I'm not going to assign a lot of these on a quiz or a test. They take a while. They're not even there yet. All right. So let me go ahead and circle what I'm going to be dealing with now. So from this point forward, let's see. Let's go with I don't know, this color. I'm going to be working with. I'm going to be working with this guy, and you know what? Let me take that back because I'm going to use that for my answer. Let's be the same color, but just bigger. I'm going to be working with this guy and this guy. All right, so let's go ahead and start a new slide. For A plus L equals 23,000. And the other guy was 15A plus 6L. equals 174,000 minus 33A. 174,000 minus 33A. Let me go ahead and just have it so I have all my A's and L's on one side for this guy. So if I add 33A to both sides, that would become 48A plus 6L equals 174,000. This probably looks like it could definitely be, these both have 6 as a common factor. 174,000, 7 plus 4 is 11, plus 1 is 12. This is divisible by 3 and 2, therefore it is a multiple of 6. Someone with a calculator, please help me out. If I divide this whole thing, by 6, what do I get? Yep. So we have 8A plus L equals 174,000 divided by 6, please. 29,000. Thank you. Okay, so this guy is here, and let's go ahead and now I'm going to just bring this guy right here underneath it. So we have 4A plus L equals 23,000. I think it's pretty clear here that I'm going to eliminate these L's. It's very convenient. Let's go ahead and do that. So I'm going to subtract this whole equation, all its components from this one. 8A minus 4A is 4A. And then L minus L is nothing. And then now 29,000 minus 23,000 is 6,000. Just to let you guys know, if my phone rings, and I know you guys are in here, if my phone rings, Darby, I have to answer it. My car is being towed.
Oh,
Everything's fine. I'm borrowing a truck, but just so you know, if my phone rings, I am going to have to answer it.
okay,
I let them know too.
okay.
Okay, so we're here. 4A equals 6,000. And then, last but not least, divide both sides by 4. So A would equal 1,500. Okay, so to see if I made a mistake, or to see if we made a mistake, or you made a mistake, when you're doing these, I think, okay, well, let me jump over to my original statements that I made. We said that from the text, it tells us that the sum of all of the sections, there are a total of 23,000 seats. So this number does not exceed 23,000. It may be reasonable. Okay, so if you get to something that's totally out of whack, that doesn't make sense. The number of seats A is, say, 24,000. Anything above 23,000. Okay, I made a mistake. I need to figure out where I made a mistake, because you don't want to keep going further into this 3 variable systems, knowing that you've already made a mistake. So far it looks like we're so far so good. So now that we're here, we're going to go back to, and it doesn't matter which of the two variables that we made, right? The ones that I brought over to here. It doesn't matter which of these I plug in. It should not matter which one I plug in the 1,500 for A. Okay? I think we have a simplified form, the 4A plus L equals 23,000. I'm probably going to choose that one just because it's, you guys can choose whichever one you want, whichever is more convenient. This one or this one. I'm going to go ahead and choose this one. 4A plus L equals 23,000. So let's go ahead and do this. I'm going to run out of room here, so let's shrink this a little bit. You guys can still read that in the back? Mm-hmm. So good? Okay. So now just substitution. 4A plus L equals 23,000. So let's substitute 4 times 1500 plus L equals 23,000. 4 times 1500 is 6,000 plus L equals 23,000. And therefore, subtracting 6,000 from both sides, L would equal 17,000.
So did the 4 lose the A?
What's that?
Did the 4 lose the A?
Did the 4 lose the A? No, we're substituting. We are substituting, good question, we're substituting this in for our A, because A is 1,500, so that's, I'm substituting into the A, because A is 1,500. So far, it still seems pretty reasonable, okay, because the total number of seats in this amphitheater was what? 23,000? If I go back to that, the total number of seats is 23,000. Okay? Now you're at your very end. You've solved for A, you've solved for L. The only other missing variable was the other one, which was B. And this is when you go back to your original statements, and I'm going to pick the easiest. I could pick B equals 3A. That works. So B equals 3A. B equals 3A, and that was actually my first one to go ahead and label that so it's clear. So this was my first equation. One of my original 3, B equals 3A, so B would equal 3 times 1,500 equals 4,500. Okay? So this is B. So we've solved for A, B, and L. So if you have time, yes.
Where it says 6,000 plus L,
Mm-hmm.
you subtracted the 6,000 each side?
Yes, yes.
Can you, like, show what you're doing?
Oh, yes. So let's do that. So let's,
Thank you.
yep. So minus 6,000, minus 6,000. Anytime you guys want me to show a step that I'm not showing, please let me know. And there we had out 17,000. These are probably the longest problems we will ever work on this entire course. So that gives you a sense of relief. It doesn't get any more time consuming than this. All right, so now we should be able to, if you have time, I definitely would do it on your homework, but if you have time on a quiz or test, definitely do it then as well. These should work for all 3 original statements. So someone with the calculator, if you don't mind, please, I want to test this for 1, 2, and 3. So B equals 3A. See if that works. Does 4,500 equal 3 times 1,500? Yes. So that works. The next one, this is where I might, well, A plus B plus L equals 23,000. 1,500 plus 4,500 is 6,000. 6,000 plus 17,000 is 23,000. And then now let's see if it works for this guy here. I don't care whether you do this or this. I just divided out 5. But could someone check this for me? I don't care which one you check, whether it's this one or this one. A is 1,500. So you have, which one did you want to do? You're going to help me out. The right one. 15 times 1,500 plus 11 times 4,500 plus 6 times 17,000. What do you get? Man. So 15 times 1,500 plus. Anyone have any questions as to what I'm doing right now? Anyone not sure what I'm doing? Plus 6 times 17,000. I get 174,000. So I get a sense of relief that there's no mistakes were made, because it would be kind of disgusting to go through this again. So this, I'm going to go through and we're just going to review this one problem. I'm just going to give a general, what we did. Anyone have any questions before I go through this again? I'm not going to go through each individual little thing, but in general picture, yes. What's that? It feels like a lot. It is a lot. So, then let me go over the general picture. If you get the general idea, and this is where taking notes of what I'm saying is so important, because if you have what I'm saying in your notes and you look up your notes later, oh yeah, okay, that's the way to do these. So the first thing is this. You have to, when it's a word problem like this, you need to first let some variables, or let some variables represent the unknown quantities, right? We don't know the number of seats in section A. We don't know the number of seats in section B. We don't know the number of seats for the lawn seats, okay? Develop some equations from the text. So it said that the number of seats in section B were 3 times the number in section A. And they said that the total number of seats were 23,000. And we touched on revenue. They said $75 for seat A, $55 for seat B, and $30 for seat L gave us a total revenue of $870,000. Everyone's comfortable on these things. Let me know if you're not. Is that good? Everyone understands revenue? Okay. That's the first thing. And I can't emphasize how important this is, because if you just make up, you know what I mean, if you write it and you say, okay, you write A, you write B, you write C or L or whatever, but you don't know what it stands for, then you can be totally lost in your work. Because like, oh shoot, I forgot what A, B, and L mean. Okay? The next, we have 2 minutes, guys. Let me finish explaining this. The next thing is this. Once you have them written, I'm gonna always simplify. Let me put that out. So these are guys things we always simplify. I'm always gonna simplify. Why would I deal with this when I can deal with this? It's just so much nicer. So I found they all had a common factor of 5. You don't have to, but these are such larger numbers, I don't have to deal with them. So I divided by 5. So here are my 3 original equations. Now here's what you got to do. You have to deal with 2 of them at a time. I decided to deal with 1 and 2 to eliminate my B. I eliminated my B, I got this guy. Because I did not incorporate the third equation, I have to deal with that guy. I have to deal with this guy because I did not incorporate him when I dealt with these 2. So I have to do something with the third equation. And it doesn't matter whether I do 3 with the 1 or 3 with the 2 or some multiple of those, but I have to deal with 3. I decided to eliminate, of course, if I eliminated the b's here, here's another part of your notes. If I eliminated the b variable here, I need to eliminate the b variable here, otherwise it's pointless. Because I want to get a system of 2 variables. Now that I have that, you guys kind of probably have an idea where to go from here, because we looked at 2 variables before, but this is the big picture here, getting me here and here. Are you good past this point? Okay. Any last second questions? We have 1 minute before the bell rings at 8:27. Everyone's good. You eventually will be getting a quiz on this. Okay?